So let's jump in, get our brains unfogged. We have a really short period. So let's get some basic stuff done here. Here we go. Log base 3 of 81. Tell me how you're thinking about this problem, because you got a couple of options. Doesn't matter how you think about it, as long as you can get the answer.
I was thinking about the log rule.
Oh, yeah. Somebody's got a thinking cap on today. Oscar says, I'm going to rewrite this as 3 to the x equals 81. And then I know that x has to be 4. Did anybody think about it any differently? That is perfectly fine. Nothing wrong with that. Did they have a different thought? Well, 81 is a common enough number. You've worked with it enough that maybe when you saw that 81, you thought of it as 3 to the 4th. And then remember, when these two numbers match, the answer is the other one. It doesn't make a bit of difference, you guys. However you think about it is perfect. All right, would you on your own and check with your partner, do the rest of column A? So we did the first one together. Well, the last couple pages. Very good. Last couple pages. Come on, we should zip through this, guys. Zip, 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 zip. What'd you get for this one? 6, perfect. How about this one? 2, you're wonderful. Ooh, a little tricky here. What do we have to remember about LOG?
Base 10.
So what'd you get? 3. And then LN, of course, is the symbol for log base C. So the log base C of E is just going to be 1. Perfect. Beautiful, beautiful. All right, let's move over to column B. Let's do the same thing. Do be careful, because I think you're going to end up with some negative numbers maybe in this one. Because if we log roll this, 3 to some power has to be 1/9. Well, wait, how do you get 1 over? You have a negative exponent, right? So that one would be -2. All right, go ahead and fill in that column. I know this is easy stuff, guys. We're just trying to get ourselves back in the groove. These are easy, I think. This one right here, the answer would be 7. Would everybody agree with that? That's kind of easy. This one, the answer is 3. Right? 5 to the 3rd. But what about this? This is a little bit tricky. What do you think about that? Joe Funk? 1/2. Very good, Joe. Because again, if we log rolled it, it'd say 49 to what power gives us 7? And Joe says, well, the square root of 49 is 7, and that means the power has to be 1/2. Square root, 1/2 power. Nicely done. This one is exactly the same. This answer would also be 1/2. All right, here we go. Column C, let's just do them out loud. We've practiced enough. Here we go. Log base 4 of 1/64 is -3. Log base 2 of 1/2, -1. Log base 9 of 9 to the 6, 6. Log base pi of 1, 0. Because the log of 1, here's your logarithmic curve. The log of 1 is 0, no matter what the base is, thank you. And how about log base 1/2 of 1/32? 5. 5 is already 1 over, so don't make it -5. It's 5. All right, problem B. Using our properties of logarithms, we're going to expand this big ugly expression. And so we're going to have a log of 3, a log of x, and a log of y. All right, any thoughts on how we might start this problem? Xander.
Are we
Hey,
using
thanks for being
sums
here
and
today,
columns?
Xander. Thanks for being here today.
Yeah. Yeah, okay, are we using the sums, are we plugging them into the A, B, and C?
We're gonna figure out what the A, B, and C are. So here's the deal. Because this expression has times and divides in it, when I pull it apart into its individual logarithms, it's gonna be additions and subtractions. Before I start though, what do you notice about this?
We can simplify that.
Yeah, so let's do that. So, this is gonna be, 3 squared, x to the 5th over y cubed. Double check that, did I do that right? The reason I changed that is because I have to have a 3 in my answer. So does that look okay to everybody? Now, what happens when I start splitting this apart? What happens to the exponents? Where do they go? They become the A, B, and C, don't they? So this is gonna be 2 log 3s. It's the log of 3 squared, so it's gonna be 2 log 3s plus what? 5 log x's. Then what? Minus 3 log y. And why does that have to be a minus?
That's what we're on.
Because that's a division, yeah, that's a division. Perfect. Okay, so we got a car that's valued at $24,885. It loses 14% of its value each year. After how many years will the car be worth half of its original value? Round your answer to the nearest hundred. All right, so what's your thought on that? Well, we want it to end up, this is what it is now. Don't we want it to end up with that amount? And so, if you think about it, you've got this 24,000 number, and you're, every year, so here's after 1 year, it has this value, and after 2 years, it has this value, and eventually, you want it to end up with that value. Now, as we go from year to year, think about this as a sequence maybe. As you go from year to year, what are you multiplying by? Like, how would I, what? 0.86. Why are we multiplying by 0.86? Exactly. So remember, 14 is what you're losing, 86 is what you're keeping. So we're gonna take this 25 or 24,000 number, we're gonna multiply it by 0.86 a certain number of times, and we're gonna end up with this. Does that logic make sense to you? So how do you solve something like that? We built this nice equation. How do we solve something like this?
Can we divide the 20?
You have to, yeah. So you're gonna divide, and that's just gonna give you 0.5. And then we'll take the logarithm of both sides. So n log 0.86 equals log 0.5. And log 0.5 divided by, I got about 4.6 years. It was years, right? Hundredth, so round years 100, it would still be 4.60. Is that okay with everybody? All right, here we go. Which of the following, ooh, this is good review. Which of the following could represent the function shown below? Alright, so it's a logarithmic equation. And this is what logarithmic functions look like, normally. So what's happened to this one? It's upside down. So it's going this way, right? So automatically, can we throw out B and D? So it's either A or C. Can you tell which one it is? A. Why is it A? The asymptote has been shifted 2 units to the right. So the asymptote normally is at the at 0, x equals 0. But this asymptote, you don't see it, but it's shifted over this way clearly, and so it has to be A. Very good. The equation this would pass through which point? Now, again, you have got to be comfortable with your basic logarithmic curve. What do we know about our basic logarithmic curve? What point does it go through? that one. Right? Now, what has happened in this equation? We have taken our basic picture and what have we done to it? We've moved it H units to the right and K units up. So we're gonna take this point right here and we're gonna go H units to the right and K units up. So where am I gonna be if I go H to the right? What will my X be? H plus 1. And then K units up would be K. So 1 plus H and K. Kids will fall for that problem. I can see it now and say the answer is C. But remember, with your logarithmic curve, the asymptote is at 0. The point is at 1. So when you start moving it, you're moving 1 now. All right, which of these has a vertical asymptote at x equals -3? Raina?
C.
Raina says C. Oh, wait. C. Because it has, you said 2 and 3?
Oh, yeah.
2 and 3? So she says 2 and 3 have a vertical asymptote at -3. Now, again, in your logarithmic equation, where is the asymptote normally? At 0, right? So when you do this, now you've moved your asymptote back to -1. So the asymptote's going to be wherever that's 0. So Raina says that happens in equation 2. If you put in -3, do we get 0? Yep. Can you take the log of 0? No. That would be an asymptote. Okay, and then how about number 3? Same thing? Yeah, same thing, okay. You're right, Rena, thank you. Number 4, find the inverse of this. Right, pay attention, guys. We have a quiz coming up. Find the inverse function. Anybody remember how to do this?
Flip that switch.
Switch S and Y. Forgot to change Joy's attendance. Just a second. All right, now what do we do? Yeah, times by 3, maybe just multiply, get rid of that, perfect. Now remember, we're solving for y. So the only way to solve for y is to get rid of it as an exponent. So what am I gonna need to do?
Natural log.
Logarithm, yep, natural log, beautiful. And so ln 3x is going to equal 2y. And your inverse function is 1/2 ln 3x. Good work. I hope that's one of our answers. All right, a few more here. A logarithmic function passes through the points. Find the value of 3a plus k. All right, this looks confusing. Can we do it? Okay. Who's got a plan?
Well, that's why.
Alright, so 4 equals a log base 5 of 5 plus k. Whoa, 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 whoa. What's that? That's 1. So that equation is just 4 equals a plus k. Well, let's see if something cool happens with the other one. 11 equals a plus log base. Anything special happen there? That's just 2. Wait, there's a plus in there. So 11 equals 2a plus k? Okay, so far so good, really good. What now? Somehow solve the system. So -4 equals -a on this k. It looks like a is 7. And if a is 7, then k is -3. And I want to figure out 3a plus k. Did you get 18? No, yeah,
Here it is.
alright. Try F. Obviously, you need a calculator for it. Alright, our time's about up here. So, how many of you thought PERT when you read this formula? Yep, I read this out. Because what's the key word in there? It's growing continuously. So ending up with 1,500, starting with 320 T to 2004 QT. I just worked it out. I got 36.783 days. Rounding to the nearest thousand. Does that look okay? Alright, so tomorrow we'll finish this up. I got one more little review for you. Hopefully handle any last minute questions. And get ready for quiz.